Okay, we are on Lab 8, where we are finding certain finance values given some initial information. And so we are ready for number 4, where we are finding the present value, in other words, the principal, when we are investing this amount that we solved for in, or we're trying to get this amount here, $10,278 after 6 months. So this is the future amount. That's the A value that we're going to be plugging in to our present value formula. Okay, so we're going to take 10,278.17 is our A value times 1 plus R over N. Our interest rate was 5.5%, so we put it in as 0.055. The number of compoundings is 12, and we need to raise that. In the present value formula, we raise it to the negative NT power. So negative 12 times our time, which was 6 months, in other words, half a year. You need to put it in as how many years it was. And we also need to take out that comma. Desmos doesn't like commas. So you can see that the present value should have been $10,000, rounds to $10,000. So that was our present value if we were using a certain number of compoundings. Now for number 5, again, we're going to be finding the present value, but we're going to use the A that we solved for in part 3, because this one is also going to be using continuous compounding. So we'll put in our our A value, $10,278.82. I remember to take out my comma. Okay, so that's our A times E raised, then this time the negative NT power. Or I'm sorry, it's to the negative RT power. It's like the PERT formula in that regard. Okay. So here we see our present value should have been $10,000. The principal we would need to earn $10,278.82 in half a year at 5.5% interest would have been $10,000. Okay, so again, please notice that on problem 4, when you plug into your formula, the A that you're using is the A that you found in part 2. On problem 5, the A that you're using is the A that you solved for in part 3. But now we're ready for problem 6 and 7, the effective rate of interest. Okay, so we have our APR of 5.5%, but the question is, if you took compounding into account, what would be the effective rate of interest as if it were simple interest? So we are going to use our effective rate of interest formula here. So we have 1 plus R over N raised to the N power, and then we subtract 1 off of the end of that. So in effect, that would have been an effective rate of interest of 6%. Okay, so they say, oh, the APR is 5.5%, but really, the effective rate of interest when you take compounding into account is 6%. And finally, the last one, we'll use continuous compounding, E raised to the R power minus 1 gets us, again, 6% interest, even if it's continuous compounding.